Hi, welcome back. So today we're going to talk more about slope, but we're actually going to talk about slope as rate of change. So before we actually talk about rate of change, let's review everything that we know about slope. So in the top there, we're going to write slope. Now we know that we represent slope using the letter M. And we know if we're given two ordered pairs that we can find the slope between two ordered pairs by using the slope formula, which is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. We also could flip it. It doesn't matter if we could do y sub 1, or the first y value, minus y sub 2, which is the second y value, or x sub 1, first x value, minus x sub 2. And essentially, what that is we're finding the change in y over the change in x, which we can represent change using delta. So we could say delta y over delta x. And essentially, if we're doing that, finding the change in y, if we have a graph to look at, we could just do the rise, and I like to say rise or fall, but I'm just going to write rise here, over run, which basically means that rise, we are seeing how far up or down we go, and run is how far right or left we go to get to the next point. Okay, so that's a good review of slope. Now, rate of change. Rate of change and slope are basically the same exact thing, and that's what I'm saying right here. They both represent the change in y over the change in x. However, we use the phrase rate of change in a real-world situation where there are labels or units for x and y. So we say rate of change if we know what x stands for and what y stands for, okay? So for example, if we look at the graph over here and I ask you to find the slope of this line, well, most of us are going to look at the 2 points that are there and we're going to do our rise over run, right? So let's just count my rise over my run. Now, whenever you have graphs like this, you really have to pay close attention to the units. So if you look at the y-axis here, the y-axis is counting by twos. So instead of counting up 1, 2, 3, 4, 5, we should be counting up 2, 4, 6, 8, 10. So my rise is 10, and then my run, if you look, I am actually counting by ones. I'm just labeling every other. So then I'm going up 10 to the right, 1, 2, 3, 4, 5, 6, 7, 8. So I would say that my rise is 10 and my run is 8, which would reduce to 5 over 4. So now that's the slope. The slope is the rise over the run. Now let's go ahead and put units on my rise and my run, right? So my rise is what the y stands for, and that's dollars, right? So the top number represents $5. So I changed $5, and then this graph is laundry cost, and x is the number of pounds washed. So for every $5, I can have 4 pounds. But now, so the bottom is 4 pounds. And so what we would do then to get the rate of change is we would actually just divide 5 divided by 4, or we would want the denominator to be 1, because we want dollar per pound is what we want. And so to get that, you just divide. So now at this point, we're going to divide 5 divided by 4. And when you divide 5 by 4, you get 1.25. Well, what that would mean is that the rate of change is $1.25 per pound of laundry, right? So it costs $1.25 per pound of laundry. So now let's look at the next couple of graphs, right? So this graph is about tickets and rides, right? So we're going to first figure out the slope. So let's just go ahead and take a look at my rise over my run. And so I'm just going to pick 2 points. I'm going to start with the 113 and the 26, and I'm just going to calculate my rise over my run. Now again, pay attention. Rides, oh, we are counting by ones here. And tickets, we are also counting by ones. So we would just have to count up, right? So if I start here, then my rise is 1, 2, 3, and my run is 1. So my slope is 3 over 1, which we just say is 3. Okay? Now that's just the slope. The slope is just the number, the rise or the run. But now the rate of change would be, you have to give the units, right? So let's just go back to 3 over 1, right? The top number is 3, the bottom number would be 1. The 3 stands for Y, which is tickets, right? So it would be 3 tickets for every one ride. And so we would divide 3 divided by 1, and we would get 3. So the answer, the rate of change, would be 3 tickets per ride. And sometimes you can just put a slash for where you want the word per to go. So it's 3 tickets per ride, like that. And so that would be the rate of change. So now the rate of change has a meaning where you know that you get 3 tickets for every ride. Or it costs, you have to pay like 3 tickets to ride a ride. So that being said, go ahead and take a look at, stop the video, go ahead and take a look at B and C, and then tune right back in, and I will help you figure them out. All right, so now what makes letter B a little bit tricky is that if you look at your ordered pairs here to choose from, if you try to go from this ordered pair to this ordered pair, do we know exactly how far up we're going? We don't really. We could make a guess, right? And if I go from here to here, this is not an exact ordered pair, this is not an exact ordered pair, but this one is, right? So what we need to do is we need to start with this ordered pair and go up to this ordered pair if I'm doing rise over run. So then again, pay close attention. Over here, am I counting by ones? I'm not. Every time I go up 1, I'm really going up 2, right? So when I rise, I'm going to count 2, 4, 6, so my rise is 6, and then my run, we are counting by 1, so my run would be 1, 2, 3, 4. So I rise 6, run 4. And so that's what I would start by writing for my slope. So my slope is 6 over 4. Now, of course, that can be reduced to 3 over 2. Now, when I'm talking about rate of change, the 3 is money, right? So it costs $3 for 2 toppings because that's the X value. See what I'm saying? Cost is on top, Y. Toppings is on bottom, right? And now I'm not going to leave it as 3 over 2. I'm actually going to divide. 3 divided by 2 gives me $1.50, 1.5, which we would say, because we want dollars per topping, you would say it costs $1.50 per topping. Make sense? All right, and so then the next question I'm just asking, what is the y-intercept in this graph here? And so the y-intercept right here is 0, 14. And so then again, just a review of what does that mean? So what this means is that it costs $14 for no toppings. So pretty much like a cheese pizza costs $14. And if we want any toppings, how much do we add to the cost of the pizza? We add $1.50, okay? So it means that I'm just going to be very specific. A cheese pizza, or you could say a plain pizza, costs $14. So just really thinking about, like, what does this actually mean in this particular situation, okay? Again, the next one. If you want to stop the video and try it on your own and then chime back in, you're more than welcome to do that. All right, so this one. This is talking about our candle length in inches over time. And so if I look, let's just go from this point to this point. If I look here, I'm going to count from 10, 9, 8, 7. Well, that's down 3. So we are losing height now. So if it's negative, we're losing something. Okay, so I'm going down 3. And then to the right, it's not 1, 2, 3, right? Look at what I'm counting by. Every other number is going up by 20, so that means this is 10, 20, 30. So when I go down 3, to the right, 10, 20, 30. So my slope is going to be negative 3/30, which reduces to negative 1/10. Okay? Now the rate of change is basically going to be the candle. We lose an inch every 10 minutes. But with rate of change, we want to say inches per minute Well, we're not actually losing anything every minute. We're losing 1/10 of an inch every minute. If you divide -1 divided by 10, you would get -0.1, which you could say is just 1/10. So because the top is inches, you would say -0.1 inches per minute. So we're losing 1/10 of an inch of the candle every minute. And so lots of times when your rate of change is negative, instead of putting the negative sign there, you would just write it's a loss of 0.1 inches per minute. Okay? So what is the y-intercept? Well, let's look at the y-intercept. The y-intercept is the ordered pair 0, 10, right? That's this point up here. And then what does it mean? Well, what that means is that's our starting point. The starting point of what? Our candle length. Our candle started 10 inches long, okay? So the candle starts at 10 inches long. And I would assume that that's before you start burning it, right? No minutes have passed, and the candle height is still 10 inches long, okay? So that was just finding rate of change on a graph. And now we're going to tables, right? So let's take a look at A, water level in a storage tank. Well, we've got all these ordered pairs, and we don't have the graph. So what do we use? Well, we use our formula, right? Our slope formula. So all I have to do is pick 2 of the ordered pairs. So I'm just going to pick the first 2, right? So I'm going to pick the ordered pairs 0, 14 and 2, 10. You don't have to pick those 2 if you don't want to. And then I'm just going to find the slope between those 2 points. So let's just subtract my y values. So in a table, this is going to be x, this is going to be y. And if you're uncertain, think about independent and dependent variables, right? So if this is water level in a storage tank, as time goes by, the water level is going to decrease. So time is independent and water level is dependent, okay? So, but usually when you're given a chart, the first one is x and the second one is y. You can usually assume that. So now when I go to find my slope here, I'm just going to subtract my y values. So my y values, I'm going to use 14 minus 10, and then I'm going to do 0 minus 2. So then I just subtract. So 14 minus 10 is 4, and 0 minus 2 is -2. And then we reduce that. 4 over -2 reduces to -2. So now that's the slope. But now the rate of change, well, the rate of change would be the top is water level in feet. So we are losing 4 feet of water every hour, right? So it says feet over hours. Remember, it's the change in y over the change in x. So like the answer would have the label feet per hour. And because it's -2, we're going to say that you are losing 2 feet per hour, okay? And if you wrote -2 feet per hour, that's fine as long as you understand that if it's negative, it's a loss of something, right? And so we've got this storage tank and we lose 2 feet every hour. All right, go ahead and stop the video and try B and C right now. Remember to put good labels on your rate of change. All right, welcome back. So I'm just going to show you what I did, and I'll try to talk fast in case you've already done it. I'm going to use these first 2 ordered pairs. That's okay if you didn't. And now I'm just going to subtract. And I'm noticing that if I do 80 minus 40 and then 10 minus 5, I'm going to avoid negatives. So I'm going to do it in that order. I'm going to do 80 minus 40 over 10 minus 5. And 80 minus 40 is 40, and 10 minus 5 is 5. So 40 over 5 is 8. So my slope is 8. My rate of change is going to be, this is number of cars washed, and it's money over the number of cars, right? So 8 means it's $8 per car washed, right? So we would do dollars, because this is dollars, over cars, right? So the cost would be $8 per car. All right, the next one. Emily is reading pages of Gone to the Wind. And so she's recording, how many days she's been reading and what page she's on, right? So I'm going to take the first 2 ordered pairs again, right here, okay? And I'm just going to subtract again. I'm going to do 325 minus 185 on the top because that's going to keep me positive, and then 4 minus 2. And when I do that, you get 140 over 2, and then 140 divided by 2 is 70. So we would say the slope is 70. But the rate of change, well, that's 70 what per what, right? It's y over x, right? So what does the y stand for? Pages. What does the x stand for? Days. And when you divide, you're making it per day. So the answer to here would be 70 pages per day. And that's the rate of change. She's reading about 70 pages per day. All right, so we've done graphs and we've done tables, and in all of the above examples, we knew what the x stood for and what the y stood for because we were looking at the graph or we were looking at the table, right? But if you have a word problem, you might have to decide what x and y actually are in order to find the rate of change. And so in order to do this, you need to understand independent and dependent variables, right? So you need to understand which one determines, which one depends on the other, right? And remember, y depends on x. And so I think that's a good thing to write here, just as a reminder that y depends on x. So the dependent variable will always be on the top, and the independent variable will always be on the bottom. Okay, so let's go ahead and read this next question here. And so this is about Julia. Julia is on a hike. She's in an altitude of 400 feet after 2 hours. After 6 hours, she is at an altitude of 700 feet. So we've actually basically been given 2 ordered pairs here, but we need to first figure out what are the 2 variables in the scenario, right? So the 2 variables in the scenario are altitude and hours, right? Time. So I'm going to say here that my 2 variables are altitude, which I'm going to say is measured in feet, and time, which is measured in hours. So now we need to decide, is altitude x or y, and is time x or y? And so what we're going to do is we're going to put this in a depends on statement. So does her altitude depend on how many hours she's been hiking? Or does how many hours she's been hiking depend on her altitude? And so this one, altitude, her altitude, how high she's getting, or how high up she's getting, her altitude, or how low she's getting, whatever, her altitude will depend on the time, okay, in hours. Because if you think about it, time is, if you're thinking about cause and effect, this is another way just to think about independent, dependent variable. If you're thinking about the cause, remember cause is the independent, right? Time passes, right? And because time is passing and you are walking, right, or she's walking, the altitude changes, right? So this is the effect of that. And so effect is the dependent variable, okay? So this next little bit here saying independent or dependent, well, let's just write down our independent variable. The independent variable in this case is going to be time in hours, right? And independent variable, that's x. And then the dependent variable in this case, the dependent variable, well, that's going to be the altitude in feet. And that's going to be on the y-axis. So now that you know what x and y are, we're going to create the 2 ordered pairs, right? So, excuse me, the first thing is that in 400 feet, she's going, after 2 hours, she's going 400 feet. So the first ordered pair is going to be 2, 400. Remember, x is time and y is altitude. And then the other one is 6, 700. So after 6 hours, she's gone 700 feet. I'm going to leave out the feet. So they're my 2 ordered pairs, right? So now we're going to just go ahead and find the slope. And so to find the slope, we're going to do 700 minus 400 over 6 minus 2. And so 700 minus 400 is 300, right? And 6 minus 2 is 4. And so then I'm going to divide 300 divided by 4, or reduce it completely. 4 goes into 300 75 times. So the slope here is 75. That's just the slope. Now when I say interpret it as a rate of change, well, you need to put a label on it, right? The top was feet, the bottom was hours, and if you think about it, feet per hour, that makes more sense than hours per feet. So that's another helpful way to know that feet goes on the top. And so the rate of change is 75 feet per hour. So like her altitude is changing 75 feet every hour. So now let's take a look at B. So B is saying that the cost of a movie ticket in 2000, we're going to call this year 0, okay, so that's helpful, was $5.40. In 2016, the average price to see a show was $8.65. What is the rate of change? Well, anytime we have a problem like this, we need to decide what our two variables are, right? So the things we're talking about are years, right, and cost, right? So my variables is the time in years and the total cost of the movie, right? And we're measuring cost in money, right? And so let's think about a depends on statement. We have to decide which one's independent, which one's dependent, right? So we're going to say, okay, so does the time depend on the cost, or does the cost of the movie depend on the time? And so in this case, cost depends on time. And another way I like to think about this is think about what your label is going to be. So I'm going to write this. Cost depends on time. Think about what your label is. We're talking about cost is dollars and time is years. And so our label is either going to be dollars per year or years per dollar. Now, if you are familiar with rates and you hear rates all the time, we're not going to measure this in years per dollar, right? We're going to measure the cost, how much the cost changes over time. And then if you're still confused about independent and dependent, remember the cause is the independent variable. So the time is what's happening, right? So time, as time goes on, what's happening to the movie? Well, the movie cost goes up, right? So cost goes up here. And so that's what's happening. Because the time is going on, what happens because of inflation is that the cost of the movie is going up. So in this case, the independent variable is going to be time in years, and the dependent variable is going to be the cost of the movie, right? And we measure the cost in dollars. And so the independent variable determines what X is, and the dependent variable determines what Y is. So now my two ordered pairs here. Now be careful, because I don't want to use 2000. I'm saying we're going to call this year 0, right? We've seen this on graphs before where 0, 0, and then it would say that X is representing the number of years since 2000, okay? So the first ordered pair we're going to call 0, 5.4. And then the other ordered pair is, well, 2016. Well, how many years has passed since 2000? If it's 2016, well, that would be 16 years. So after 16 years, the movie cost $8.65. So that's going to be 8.65. Okay? Now, the slope here, we're going to find just normally, right? I'm going to just subtract 8.65 minus 5.4 over 16 minus 0. And so the change in price on the top is going to be $3.25. So it's going to be 3.25 over 16. Now, this one we have not really done one like this before. It is not okay to have a slope as 3.25 over 16, because if I were to graph this, I'm not going to be able to exactly go up 3.25. So what I'm going to do is I need to make this a fraction without a decimal. So there's two ways to do this. One way is let's multiply the top and the bottom by 100, or slide the decimal point over 2 places, right? So I'm going to slide the decimal point over 2 places. So multiply the top by 100, and I have to multiply the bottom by 102, so I'm going to add 2 zeros. So what I have here is the fraction 325 over 1600. That's kind of a big fraction to reduce, but that's okay. One thing, if it ends in a 5, we could start trying to divide this by 5, but another thing I like to notice is that it ends in 25, and 1600 ends in 2 zeros, and 100 ends in a 0, so like 25 probably goes into this. So go ahead and divide 325 by 25, and you're going to get 13 there. And then divide 1600 by 25, and that's going to give you 64. And so now we have a nice, beautiful slope here. That's one way to find the slope. Okay, so again, just a reminder, the reason we were doing this is because slope doesn't have decimals in it. We need a fraction. We need an actual whole number divided by another actual whole number. Okay, so that's one way to do it. Another way to do it is, neither way is beautiful, but over here I'll just show you 3.25. Well, that's 3 1/4, right? over 16. That's another way to think about it. And we could just divide fractions, right? We could change 3 1/4 to an improper fraction, which would be 12/13 over 4, right? And then we're dividing by 16 or multiplying by 1/16. And so if you just look at that, just multiplying, you get 13 over 64. So either way is you're going to get the slope, okay? So whatever way makes the most sense to you, go for it, okay? All right, so now interpreting this as a rate of change. Well, to get the rate of change, we just divide. We're going to do 13 divided by 64. And when you do that division, you get 0.2. And so we have to interpret this, right? That's dollars per year, right? So it's changing 20 cents per year. So that's what that is, 0.2. 0.2 would be dollars, and we're not going to say 0.2, we're going to put a 0 there because it's 20 cents per year is the change. We could also just write 20 cents per year. All right, notice if we're putting a dollar sign, you have to have that decimal. If you want to take the decimal out and call it 20 cents, that works too. Either one is fine. So basically, every single time you have a word problem like this, like I'm not going to give you a chart where you have to fill in all of these things. But basically what I really want you to be doing is I want you to be thinking through how to do the problem when you go to do it. So basically, when you get a problem like this, none of this is going to be here. But what I want you to think about is I want you to first take this, I want you to identify which variable is x and which variable is y, come up with two ordered pairs, find the slope, and then convert it to a rate of change. So it's basically what I want you to be doing every single time you have a problem like this. So as you keep going, I'm taking more and more from the chart away. So go ahead right now, stop the video, and actually go through and try C, come back, see if you're right, and then try D, come back and see if you're right. And then if you get stuck, of course, ask for help. So take a moment right now to look at the answer here. One thing I want to point out to you again is that your slope, when you go to calculate it, is 15 over 1.5. I changed that to 150 over 15, which then gave me 10. You also, if you did 15 divided by 1.5 and you got 10, then that helps you as well. And so the slope, you do want to say 10. You don't want to say 15 over 1.5 because we don't do slopes. We don't have decimals if we're trying to write a fraction, right? And then the label is miles per hour. Stop the video and try D. And so there's the answer to D. Stop the video, make sure you've got it right, and then move on to the next page or the next problem. So not all problems are going to have that chart. In fact, any of the problems that I give you are just going to look like E and F. So whenever you do these, you have to identify which variable is x, which one is y, write your ordered pairs, find the slope, and then find the rate of change. I encourage you to take a moment to turn off the video and try E and F on your own and then come back to me to see if you got them correct. So in letter E, I would say that the x is the days she's been gone on her vacation, and the y is the number of emails she received. Because what we want here is how many emails did she receive per day. So on the first day, she received 26 emails. On the on the fifth day, she received 126 emails. So I'm going to find the slope. I'm going to do 126 minus 26 over 5 minus 1, which then in turn gives me 100 over 4. And 100 divided by 4 is 25. So she receives 25 emails per day. All right, if you haven't tried F on your own, seriously, turn it off, give it a try.